How's it going, everyone? Welcome, Eulier Gonzalez again. Today, let's going to explore now about this Git, and this is a course taught by the Prime, a software engineer that has previously worked at Netflix, and I think he's still currently working at that. So why we are actually looking at this? Because like with any tool that we're gonna use, so for example, if a client asks you, what is this? What is the value of this? And how you can use that. So what is the benefit? What do I get that you as a developer know about this stuff, and then it helped me with my business. So this is a course to actually to walk through how this stuff actually is going on behind the scenes, which is one of the things that I really love about the Prime approach, is the walk-through approach of how things work. And again, the TLDR of this is that to understand now how Git works and the value proposition of that. So any time that, for example, we need to do some merge or rebase or reread, we know what's going on behind the scenes. So this is a very small course, a very deep also, because we're gonna look at the 80% of the commands to get all. We're gonna apply this Pareto principle. So we're gonna do the 20% of the effort to get 80% of the results, and by looking at how Git data structure works, we can now understand that what is doing behind the scenes anytime that we do some of the command that I mentioned. And the idea here is that we know that, and we can say that, hey, Git is a magical tool, not because it's a mysterious box, but because we know what it's doing behind the scene. And that looks like magic. Now, so the introduction here is that at the end of the day, this was invented by Linus Torvald because he is so smart that he can hold the entire Linux core on his head. So us developers, like the rest of us, we're just mere mortals. So he created now the Git or this annoying tracking file system. So this is also the role of a lot of tech leads, that they can hold the entire architecture and program on his head. So anytime that they need to make a change, they know where to look and apply that. So if a bug fix, a change, so on. So we will look at the Git basics of what Git is all about, which is this distributed version control, which is AKA it allows you to store a local version of the program, and you can now from a commit recreate that. So why this is powerful? Because now you can have a local copy or a local version, apply some of your change, and then sync with any other computer, usually a server, a Git server. So the value of this is that we can now, or this enable is all of this CI/CD process, right? This continuous integration, continuous delivery, that we can now integrate all of our codes, regardless the Y amount of contributors from different backgrounds that they have. Also, we look at the most common commands or the terminology here. So for example, like a repo, which is the project that Git is tracking, the commit, which allows you to recreate the entire project from one of this commit or one of these hash that is stored in an index. And then we have now three phases or three places we can put our work. You have now the on track, the stage when you add something to that, and then also the track when you commit to that. also known as the working directory, working tree, in yeah, those two stuff, and also how now Git organize all of these different commits, right? This is an acyclic graph, and we're gonna see that what it means. But at least to understand that we went through set up a Git config, that at the end of the day a config, or first set up a Git project, and that is now creating is a folder on the .git. So let me actually show you right now. Where it is, functional light, you got it. If I go here and I clear the console a little bit, right, and then I say, hey Git, find .git is find find.git, all right. And as you can see, once you initialize Git, it creates now a folder on a hidden folder that contains all of this different data structure that it's going to use for keep tracking that, as well as the config file and some of the hooks. So we're not going to dive deep into the hooks. This course is not meant to be to you to explore this kind of stuff. It's just to know how Git data structure works and what it's going to do anytime that, for example, we use now the most common command, which is git git status, git add, git commit, and also some of the branching techniques and merging solutions. So yeah, so we look at, this is the folder structure that it creates, and as you can see, there is some object folder here. So anytime that we, for example, add something to our tracking area or to the working index, all right, we're gonna see, or we commit that, we're gonna see that in our log, all right. So if we want to actually look this log in a much more meaningful way, we can say, hey, git log, show me with the graph version, okay, and then show me with the decorate here, right? As you can see, we're actually now is looking at this. So this is our first commit, and as you can see now, anytime that you make a change to, or you add those files, those file change to Git, or to the working tree, to the state, to the tracking area, all right, it has now a commit, which is a SHA, secure hashing algorithm, that is made of alphanumeric number from 0 to 1 and A to Z letters. It is made of, I would like to know the length of this. Could you give me the length? Yeah, give me the length here. Okay, 40. Interesting. It's a string of it's a 40 length string here, all right, where now the first 7 are used to identify a commit, right? So with that, this is 3, the first 7s are used to identify the commit, and as you can see, the initial commit only is the author and the date, right? So if we now want to explore is what is the content of this commit, because remember, at the end of the day, now a commit is just a node on this acyclic graph that has a relation of child to parent, child to parent, or anytime you make a change, it does reflect that as a new child that has a relationship with the parent. All right. So if we want to explore now is what this commit contains, or we can explore that with the cat file minus p. All right. And then only with the first 7 you can have access to this. Look at this. So here, that commit, which is a node, contains data, several contains some property here. That is the tree, the author, and the committer. And as you can see, this is now the initial commit because it doesn't have any pattern associated, right? So this is the beginning of this. So you have now the tree, the author, and committer. So for to make it easy, the tree is just for a folder structure that when you again wants to get now is the first 7, but for this moment we're gonna get all of this, and then you say git, why git show? Oh, this is another way of how you can actually visualize this. All right, but this git cat file here, which is the commit that we want to extract this data, is now have a reference. It has now a new hash that has a reference to the file that was changed. And then if we go down to this cat file minus p, all right, it now has the content of that file. Again, it has the entire content of the file. So the idea here is that by walking through this way of how now Git store or change, that at the end of the day, it is storing is the entire project along with its change. Okay, so from this commit we can recreate the entire program, and it's doing that because now it's holding reference to from the commit to the file that contains the content, right? So this is the reference that is managed, that is using that. And I think this is quite interesting because now we're starting to see is this relation, this acyclic graph. So any commit, as you can see, it has now a hash that is pointing to the file, and that file now pointing to the commit, right? So all of this commit has the same structure, as you can see. So it makes an acyclic graph because you can have now multiple patterns to that, which is something that we're going to see in today's video. So and if you want to explore now the Git folder, as you can see, those reference here like 9A and AC actually now live here, AC and 9A. If you want to look at the Git log, that in our case is 56 and A6, all right? So if we want to look at that, we can see that we have now 56, which is our second commit, and then the A6, which is our first commit, right? And all the data associated in that. But as you can see, it's now storing all of that data, right? That's quite mind-blowing. That's quite mind-blowing. So this commit here, which is the content of this file, because at the end of the day, which is something that to me was now a revelation, is like, oh, Git doesn't know the state of this. It needs to read the file, it needs to go to the configuration file, for example, to actually now say, okay, I know where I am. So Git, in some sense, is stateless in that regard. So yeah, here we are. This is 9A, 9B1, like this. So if we inspect now this, if we say, hey, git log or git cat file p, or for example, if we say now, I want to know the content of this, or I want to know the content of the git here, git the object the 56, no, actually the one who has the content, which is 9A, followed by that. As you can see, you have a lot of nonsense. You know, this contains a lot of nonsense. So if you want to actually have access to this, you say git cat file with the name of the commit. So Git now transform that into the data set. So perhaps what it's doing behind the scenes is now trying to explore where that file it is, okay, in the entire data structure, and then do some sort of transformations to get the content of that file. You can actually do that git cat file here to explore now the manual, right? And here we can say cat file. Yeah, cat file we got is this. As the next one, like this, is provide content or detail of repository objects. It doesn't tell you what it's doing behind the scenes, but this is part of the command, interrogation command. Right? You also have manipulation commands. And this is just looking at the low-level commands or the plumbing commands, right? So we're quite familiar with the porcelain command, okay, or ancillary command. As I mentioned here, the high-level command or porcelain commands like git add, git m, archive, bisect. I don't know what it is, but we're gonna see that. Use binary search to find the commit that introduces a bug. So we're quite familiar with git add, which is porcelain, git checkout, git switch, cherry pick, maybe. We're gonna see that in a moment. Lock, merge, pull and push, and rebase, which is something that a lot of the time we need to go with. Git stash as well, so stash the chain in a dirty working directory away. All right, so this has now like a separate working directory, which is a great stuff. You can put it. So let's get into what we really care in today's video, shall we? And that is branching and merging strategy. So the TLDR of this is that with this git basic, we also went through now how can we explore is the configuration file, how can we add now sections and key, for example, all right? And yep. Okay. And also we look at the basically like how you can add a configuration file, how you can inspect the configuration file. It's gonna do this, right? So for example, hey, I want to now is read the configuration file and say I want to list all of this, whatever you had, Okay, or you can say git config get get regex, for example, that start with this, all right? Or you can say git config dot list, and using now the Unix terminology, which is get me is all of those that match with, for example, fen, right? Fen.mark is okay. So the exploration here is just to now knowing that anytime that you have access to the git configuration file, let me actually zoom in a little bit. So anytime you need to access the config file, you at some point needs to say, all right, or think that Git doesn't know anything about this. It's gonna look at the config file that lives inside of this folder structure, and if it's fine, good. If it's not, not. So in some sense, as I mentioned before, Git is a stateless, right? So this is git config list as well. With git config, okay, there are several commands. So for example, like list, or you can say git add, whether you can say, hey, I want you to now, for example, is to modify is the initial name branch, whether it's local or global, all right? So in our case, if we do something like this, to get all of the lists, we can see that, I think there is another version here, git config. Yeah, but git config, let me read the manual here. Config config, oh, go back. Configuration mechanism, Git use a simple text format to store customization that are per repository and per user. So your configuration may look like this, all right? The question is the git config one. So it means that if I say git config, okay, but git config, it's not that descriptive, bro. Okay, git config is a git config and the list get set unset rename section and edit. Okay, so in this case, what I want to do, git config list, comment all with get return result value for a multi-value key, okay, and replace all. List all variables set in the config file along with their values. So we can say something like git config list, say git config list, you got this, all right. I want to now look at in format that I think is this, git config list all. You say no, doesn't work that way, okay. Let me explore the docs here. Okay, this is if I want to, okay, makes sense. If I want to read the content of the file, I say cat, and I want to know why cat. Concatenate, okay, concatenate and print file. Okay, whenever you have this, the cat utility, read file sequentially, write it then into a standard output, and the file operands are processed in a command line order. It's because this read the file sequentially, and then writing the standard output this. So concatenate and print file. So concatenate, which means that read the file sequentially and then print that out. Okay, so I want to now, well, have access to the config file, which is a text base, and that makes a lot of sense. So as you can see here, all right, we have changed is the default init branch to trunk, all right, which is something that you can now work with. So you have now is the git config, how you get yourself familiar with the git config, also the anatomy of the git config, where you can add is, for example, utility data under the section with the key and the value, all right, and let me make a quick pause here. Okay. For example, you can also modify as the global variables. So now this is something that we are quite familiar, especially if you're gonna work with Git when you want to config the local files, right? And if you, for example, say git config list, here you can see now is the global variables here. For example, hey, the user name, the user email, some sort of filter that you might have, and so on and so forth. If you want to have access to that Git repo by saying, hey, concatenate all and print that out. So let's go into now look at the exactly where you say now git config. So git store now global configurations under your root folder and local configurations on your based on projects. All right, so here we can see it's like, hey, now we're using is the name and the email, which is in my case, I shouldn't show you this, but in any case, and also the filters and so on and so forth. So that's great. That's also very, very great. Holy moly. And that's right. So let's now get into the the branching. Good.
We're going to go into Git branching. First off, you should not develop everything on the main line. Okay, that'd be kind of crazy if all you ever did is just simply use whatever your main line is and just put all of your changes on that. But I'm going to be a little honest with you guys. When it's just my project, I only develop on main. That's it. That's all there is to it. But if I'm working with somebody else, you should branch. Branches are pretty much cheap. They're almost free. So you can create as many of them as you'd like, and it's really not going to create a problem for you, for your system, for memory. Again, every branch will be pointing to a commit, which will contain the entirety of your repo, but they're free almost at the exact same time.
Exactly. So that's
we'll find out for your system, for memory. Again, every branch will be pointing to a commit.
Every branch will be pointing to a commit. Interesting. And so every branch will be pointed to a commit. Pointed to a commit. All right.
Which will contain the entirety of your repo.
Exactly. So every branch will point to a commit, which will contain the entirely of your repo,
but they're free almost at the exact same time. Entirety of your repo commit, which will contain the entirety of your repo, but they're free almost at the exact same time. We'll find.
But they are free. Yeah, but they are free. But they are cheap, most likely.
For your system, for memory. Again, every branch will be pointing to a commit, which will contain the entirety of your repo, but they're free almost at the exact same time.
At the exactly same time. It makes a lot of sense. It makes a lot of sense. It makes a lot of sense. So every branch is pointing to a commit, to a commit, which will contain the entirety of the repo, but they are free almost at exactly same time.
We'll find out why. Since we're on a new repo, let's create our initial commit, because remember, whenever you start a repo, there's no commits in there, so it's empty. You can't even create a branch right now. Things.
Okay, this is a problem. So problem. Okay. Nope.
Things are all goofed up. So let's just create a quick change, and I want you to have a readme.md with one line, put A in there, and then with a commit message of A. It's very important that you use these commit messages more than anything else, because if you don't, you will probably get a little bit confused with the course. So I'll do it in with a commit.
So we'll be using a hello get. You just created previously to test the trunk. Okay. So we'll be using the hello get you just created previously to test trunk.
Message of A. It's very important that you use these commit messages more than anything else, because if you don't, you will. We're gonna go over some config format. Okay. You move all the keys. Use SVN tortoise, and so due to remembering, go to hello get, and I'll go. We're gonna go into get branch that you use these commit messages more than anything else, because if you don't, you will probably get a little bit confused with the course. So I'll do it too. Readme.md. I'll put in a nice little A. Get add this. Get status. Get commit. By the way, always use status before you commit. Make sure you don't accidentally say commit in out file by accident while teaching a course on Git and showing people how to properly use it. And of course, message A, because we want to keep track of this. Okay. So there we go.
All right. Trunk root. So let's gonna create now this simple exercise right now. This exercise is just to now create a read file. Oh, git status. Oh, but I haven't changed that branch, bro.
Commit an out file. Readme.md. I'll put in a nice little A. Get add this. You have a readme.md.
Okay, so let's going to create first is okay. So what we're gonna do is to understand now this branching, what is doing behind the scenes. So first, let's going to create now a file called hello get. Make there hello get. All right. I should let me remove that hello get from here. Go back here and say, hey. I'm gonna create now. See the hello get when you have access to hello get. All right, and this is interesting. We'll be using is you just created previously that to test trunk default branch setting.
We're gonna go over some config now. It's good unset among. We remove naming your default project right, and I'll go to hello get, and I'll go get init.
But again, this is because we initialize them globally.
Quick thing, let's actually, but which one should show up when I do get fem.dev? Which one do you think should default branch? You can choose whatever name you want. So I'm gonna do a little global and go trunk. I just want everyone to feel the pain. Yeah, no, exactly.
Exactly. So what we're gonna do here is do this. It's like, hey, we want us to now add the config file, global settings, and set the init. Please show me the list and say now the init. Where it is. Really? Remote branch. Origin URL. I cannot believe it. Where is it? If I say cat config. Yeah, but cat of the git config file. Oh, so it's because we don't have any of that. Exactly. But I want to now init default trunk. This is something that I don't like it. I definitely don't like it because it doesn't show me that. Credentials, user, filter, core, remote branch, and you. That's mind-blowing. That's mind-blowing. That's mind-blowing. So if I want to look at the git config global list, init default branch. So if I say git config global set init default branch, okay, like this, init.default branch that it will be now called trunk. It say, hey, I don't have that. Git config global init.default branch called trunk. It did that. All right, so if I say here git init, now we initialize that repo as trunk. Okay,
I want you to feel it. So there we go. We've now named our initial branch. Obviously, should this be local or global? Should be global if you want it to take place for all repos for all time on your system. Remember, we just got done naming your default branch to trunk. So if you forget that you did this class and you create a new repo, it will have trunk as its default name, and then you'll be triggered due to remembering SVN. So real fact, by the way. So let's try it out. Let's just go and create a project right now. Call it hello git. This is important. Call it hello git. And do a git init inside that folder. So I'm going to go back. I will make my own dir. Go and create a project right now. Call it hello git. This is important. Call it hello git. And do a git init inside that folder. So I'm going to go back. I will make my own dir. Hello git. And then I'll go to hello git and I'll go git init. Look at that. It's now trunk. There we go. So git has global settings. You can change your experience. There's actually.
So in other words, what it's doing behind the scenes is create this particular git folder, right? that doesn't have anything. They just only have the information, the tracking information, all right, and some of the hooks. All right.
Actually quite a few experiential changes you can make to Git. This is just the easiest one to demonstrate with no Git knowledge. We're going to go into Git branching. First off, you should not develop everything on the main line. Okay, that'd be kind of crazy if all you ever did is just simply use whatever your main line is and just put all of your changes on that. But I'm going to be a little honest with you guys. When it's just my project, I only develop on main. That's it. That's all there is to it. But if I'm working with somebody else, you should branch. Branches are pretty much cheap. They're almost free. So you can create as many of them as you'd like, and it's really not going to create a problem for you, for your system, for memory. Again, every branch will be pointing to a commit, which will contain the entirety of your repo, but they're free almost at the exact same time. We'll find out why. Since we're on a new repo, let's create our initial commit, because remember, whenever you start a repo, there's no commits in there, so it's empty. You can't even create a branch right now. Things are all goofed up. So let's just create a quick change, and I want you to have a readme.md with one line, put A in there, and then with a commit message of A. It's very important that you use these commit messages more than anything else, because if you don't, you will probably get a little bit confused with the course. So I'll do it too.
So
readme.md, I'll put in a nice little A, git add this, git status, git commit. By the way, always use status before you commit. Make sure you don't accidentally say commit an out file by accident while teaching a course on Git and showing people how to properly use it. And of course, message A, because we want to keep track of this, okay? So there we go. You can do a little quick git log and see, look at that. A, fantastic. And of course, message.
And of course, this message is with A. So what it's doing behind the scene is that by the time that we create this commit, it will create now is a commit or a SHA with a length of 40. It's a 40 string length alphanumeric that it has to. All right. So trunk, root commit, and all that kind of stuff. One file change and one insertion, as you can see here. And if you want to now inspect that commit by actually putting just only copy in here and say git cat file that. All right. So here you can see, well, actually it's now containing the tree, outer, and committer. So this is now the first element. And if we want to go down to what this commit is now pointing to, which now this commit has the entire repo. Okay. If we grab the the first 6, right? It will now have a reference of the file as well as the file. Okay. So this commit have a reference to, so the commit on the tree property has a reference to the file, and that file has a reference to the actual content of it. And that's quite interesting. So git cat file here to the actual content of it, which is in this case A, right? Good.
Message A, because we want to keep track of this, okay? So there we go. You can do a little quick git log and see, look at that. A, fantastic. All right. So let's create a branch, and we're going to call this branch foo. Wow.
Yep. So let's go to create a branch. So here we go, right? So after we create that, we commit with that. This is what we create here, right? So far, so good. The solution, this is Finder. There you got it. Okay, cool, awesome. All right, great. So we're gonna call this branch foo. Why?
Why? Because I say so.
Okay. So this is another problem. For creating branches. So it's creating branches.
So I know some people hate foo and bar as example things. I love foo and bar. Okay, I don't know why everyone has to hate foo and bar. It's fantastic. All right, so get branch foo. This is how you create.
So this is how you create is now a branch. Git branch, which is what is doing behind the scenes, is now have a reference to that commit. All right. In your case, you're gonna have a reference to the last commit. In our case, this one. Right. So git branch. You can do as branch, or you can do a switch -c. All right, not quite. I don't know what the subtle difference between both of them. So, for example, git, and if you want to create now, say branch, list, create, or delete branches, switch branches, or restore working tree files. Switch branches, branch. But this is git branch. Nope. Git branch. If I say I want to read the manual of git branch. Okay. List, create, or delete files. Pretty straightforward. Yes. What is the difference between this with the man git switch? All right, switch branches, switch to a specific branch. The working tree and the index are updated to match. The working tree and the index are updated to match the branch. All new commit will be added to the tip of this branch. All new commit will be added to the tip of this branch. Optionally, a new branch could be created with either C or C automatically from a remote branch of the same name. Or detach the working tree from any branch with detach, along with switching. Switching branches does not require a clean index and working tree. Switching branches does not require a clean index and working tree. It has no difference compared to the head. The operation is aborted, however, if the operation leads to loss of local change, unless told otherwise with discard, change, or merge. This command is experimental. The behavior may change. So, in other words, good, but since the behavior may change, it makes not that suitable. Creates a new branch, a named branch, starting at the starting point before switching to the branch. This is the transactional equivalent to say equivalent of git branch, new branch, and git switch. That is to say that branch is not reset created unless git switch is successful when the branch is in use in another work tree. Not just to the current branch stays the same, but the branch is not reset to the starting point either. So I prefer to use now git branch. I prefer to use git branch. So again, git switch is an experimental behavior. There's nothing wrong with that, but I prefer to go with the git branch. And you put the name here, say git branch foo. However, what happened with the branch is that it won't switch you to that branch, unlike with switch. All right. So it only creates the branch, but it doesn't switch you there. That's why you need to use is the git checkout to do that.
Create a branch. We just created it right now. Was this your expectation when you create a branch? Yes or no?
Yes, but I'm used to it.
Yes, because you're used to it. That's actually the proper answer right there. For if you're new to Git, that was a weird experience. You just created a branch and nothing happened, right? You're just still sitting there. You're on trunk. Where am I? Why did this happen? I want to go home. Well, guess what? You already are at home. The thing is that when you create a branch, it creates a branch at the commit you're currently on, but it does not switch branches. There's actually a couple ways you can. First off, you can check out any branch you have.
Exactly. So Git branch doesn't switch them. So Git branch doesn't switch to the newly created branch from the last commit you are. Okay, so that's why we can use git switch or git switch with a -c, or git commit, or git checkout to move from, or to move forward, or to move on the branch, on the newly created, on the new branch.
So I can actually execute git branch. You should do this right now. Use git branch, check it out. I talk about log as well. So you can go git branch, check it out. You see, I'm still on trunk, but I do have a.
If I say git branch, I'm have trunk. Exactly. So if I run this, so if you run git branch, in our case, we'll see this. Right.
Foo now. If you go git log, you'll see head points to trunk. That's where I'm at. But there's also foo. Foo's at the exact same place. Because remember.
Git log for that's right. So this is quite interesting, because now you can see is that it's now pointing to trunk and also to foo, right? If we use git log, we can see that in action, right? It's pointing to trunk and also to foo.
Remember, when you create a branch, it branches off wherever you're at this moment. Very important. Some people only know that by accident. They haven't really ever thought about it, but yes, it's literally pointing to the same commit. Wherever you're at.
When you create a branch, it branch off wherever you are. So any time you create a branch, it will point to, or it will branch off. Exactly. So anytime you create a branch, it'll branch off the commit, or it branch off wherever you are, or it branch off whenever you are.
At this moment. Very important. Some people only know that by accident. They haven't really ever thought about it, but yes, it's literally pointing to the same commit. Let's do a little bit of git foo. Can you find your branch details in .git?
Can you find the branch detail in Git? Well, yeah. Can you find in this case, you can say cat or git or find the git. All right. So here we're not able to see is this last commit we create. So git log here, which was this 367, and then you say, hey, git cat file of this first. You get is this, okay? So yeah.
See, look, take a moment, explore.
Ref's head's foo.
I'll give you a little hint. Go check out refs. So I'll go like this. Get refs heads, foo and trunk. Look at that. So I can actually cat that out. Hey, that's my SHA. The branches just exist in this heads folder, and it's just a SHA.
So you can actually cat that out.
A little hint. Go check out refs. So I'll go like this. Get refs heads, foo and trunk. Look at that.
So as you can see here, so if we zoom out a little bit or a little less in our case, right? And as we can see this, and as we run this command, and now we can see that. So can you find the branch in git folder? All right. So as you can see, we find it in our refs folder. It had the heads and also had the tags. Okay, and again, remember that any time you create a branch, you are branching off whatever you are. Okay, and that means that this branch is pointing to a commit, and that commit contains the entire repo.
So I can actually cat that out. Hey, that's my SHA. The branches just exist.
So if I want to have access to that and say cat dot git slash ref slash dot head slash dot trunk dot foo, hey, look at that, we have now the commit. All right, so it's literally that. Holy moly, it's literally that, bro. Holy moly. So it's literally that. Okay, yeah, so it's literally that. So that ref or that branch that was created is literally a commit to that. It's pointed to that commit, bro. That branch, yeah. The branch just exists in this heads folder as just a
in this heads folder, foo and trunk. Look at that. So I can actually cat that out. Hey, that's my SHA. The branches just exist in this heads folder, and it's just a SHA.
The branch just exists in this folder, or the branches just exist in these folders as exactly. The branches, because it's multiple, the branches just exist in these folders under the ref folders as SHA.
So that's Git. Remember, what did we do with a SHA? When I cat a file of a
Is that remember? And remember, what we are doing with SHA is to cat a file that contains or to cat, with SHA is to cat, and remember what we're doing with the SHA is to cat a file that contains the tree, that contains the commit.
SHA, right? I go get cat file dash p. It then shows my tree, right? So this is how Git kind of understands and is able to build the state of your repo.
Chill. Exactly. So and remember what we're doing with a SHA is to cat a file that contains my tree, okay, that exactly that contain my tree, or that contains my tree, that that contains my tree, that's contain is the SHA of my file, which contains a SHA of the content of the file content. Interesting. So it's managing all of this reference, and this ref is just now a SHA, a commit that is branching off when you create your branch at that moment, whenever it was that moment, that allows you to do this.
It then shows my tree, right? So this is how Git kind of understands and is able to build the state of your repo based off of a branch. As a branch is just a SHA,
So this is the way how now Git understand how to keep tracks of the files in your repo, when you create a new file or when you create a new branch. Okay, so a branch, interesting, a branch is just a SHA, all right, that contains the commit. Okay, a branch is just a SHA that contains the commit. Exactly, a branch is just a SHA that contains the commit, that contains, exactly, a branch is just a SHA that contains the state of your repo, which is your commit.
SHA is the state of your repo. It's not a differential. That's why it's always able
Is not a differential
to do it and do it so fast.
That's why you can read or write so fast. But at the end of the day, it's this. So now it makes a lot of sense behind the scenes is how the things is working, bro. Holy moly, bro. So a branch is just a SHA that contains the state. So a branch, anytime that you create a branch, which is going to create now a reference, okay, it's gonna add this SHA to this folder under the ref that contains the state of your app, of the state of your repo, the project that is being tracked of.
That's why branches are effectively free.
That's why branch are effectively free. Because they just hold is a reference. It's just a 40 characters in the file.
Just 40 characters in a file.
Exactly. It is just 40 characters in a file under the ref folders. Shit.
End name. So it's like 45 characters for our
End name. That is just 40 characters. The SHA and the name in a file. Holy, oh.
our case. Anyways, so if you want to switch branches, you can actually do git switch or checkout. I'm just used to using checkout, so I just use checkout. You can use switch if you want to. They're effectively identical for the standard cases. I read on the internet, so it must be true, that checkout is more versatile, but I only use checkout to create a branch or to switch to a branch or to do something with merge conflicts, which we'll talk about later. So pretty much I just use it for the most basic operations. And so switch to branch foo. So I'll go get checkout foo. Look at that, we're on branch foo, how fantastic.
And what it's doing is that we are now if we check out to that, which is something that we did. No, so get checkout trunk to foo. Look at that, we are now we are behind the scenes is under. So behind the scenes now git is at this commit that branch was switch off. We are now pointing to the commit where we branch off this, where the branch was created. Okay, so we are now at the point. We're now pointing. Okay, so foo is now a commit where we branch off. Foo is the commit. So foo is this branch that points to the commit at the time that we branch off. Okay, and that's quite interesting because those ref or aka those branches, as you can see here, right? Those branches here now live under the ref, right? Foo and trunk. Okay. They now live under the ref here. And those are just 40 characters plus the name, so they are virtually free. Of course, there's nothing free at all, but they are virtually free because they just only contain is now the commit that holds the state of your repo, of the project that is being tracked of. Oh crap, nigga. Holy crap. So anytime that you are switching to a branch, what you're doing is just telling to get to look at the commit that to switch off to the state of that repo, to switch off to that particular SHA that contains the state of that repo, a reference to the state of that repo.
Oh, it's beautiful, right? There we go. It even tells you you've switched to branch foo. Awesome. All right, so now let's actually add some commits to foo. We're gonna add 2 commits, B and C. Make sure you actually use B and C because it makes everything easier to use that. And I have a small typo right here saying add the changes to README. Don't add them to README. Add them to a new file. I called the file second, and so you can do the same thing. All right, so I'll go echo B into second. Remember that. Git.
Okay. Interesting. Another file in the file called secondmd.
Add it, git, commit it.
Okay. Git, or in this case, echo when you say now B echo B
and I'll do it again with C.
To second.
Fantastic. Now I have 2 commits into foo. We'll do a git log just to prove it. A, B, C, right here.
Second. Git
awesome. I'll give everyone a moment to catch up. All right, so you should now have the repo.
and then git commit with -m. That'll be called as B, right? Or in this case, B and C. Okay. Okay, and let's go to create now another file. In this case, echo C, and concatenate that output or append that output to the another file, which is second.md. Okay, and you say git status, git add to second.md, git status, git commit, which will create now a branch, which create now is a SHA based on the user email, name, the content of the file, the time, that is going to point to the current state of the app. In other words, that it contains now is a tree, which is the folder structure, that contains now a SHA or a reference to the file, and that file that contains a reference to that file that now has a reference to the content of the file. Okay. And then you got it. We actually
git log just to prove it.
Say git log this one. All right, so we add the A, B, and C.
A, B, C right here.
And as you can see now, this is where trunk it is. All right, add that commit, and then we add now some change. So the head is now foo. Is pointing to that.
Awesome. I'll give everyone a moment to catch up. All right, so you should now have the repo set up like this. A should contain trunk. B and C should be foo. We can go git log, just verify that trunk's at A, foo is at C. Awesome. Foo C. There we go. This is what I pretty much executed right here. We added those two things, and when we do the log, you can see trunk's down here, foo's up here. Remember, your commits won't match my commits. Totally normal. Again, totally based off of time, author, everything. Remember, you can delete branches. I don't know if you know that. You do the D command. We will actually use it later. I'm just putting it in here. Just remember, -D deletes a branch. I always use capital D because I don't want it to have to try to check against the origin to see, oh, can I delete this branch? Is it up to date with what I'm tracking against? We'll go over tracking and all that later on, but I just use capital D whenever I'm deleting something. Old habits. All right, so now we have a branch full of changes. What do we do next?
Go home.
Merge. Did I hear merge? Yeah, absolutely. We got to merge it. With the previous section, you should have this set up. Hopefully everyone has this set up. So now we're going to need to do the exact same thing to trunk, except for we want to have D and E. This time, I do want you to edit the README file. So the read.
All right, so let's now go with the merge right now. Okay. There you go.
README file will contain 2 or 3 changes now, A, D, and E. And then we'll have a second file called second.md that's only on foo. So to be able to make these changes, you first have to check out. With the previous section, you should have this set up.
Okay. So now that we know what the branching is all about, then let's go to merge now. Oh, it makes a lot of sense. Merge. Holy moly. Holy moly.
With the previous section, you should have this set up. Hopefully everyone has this set up. So now we're going to need to do the exact same thing to trunk, except for we want to have D and E. This time, I do want you to edit the README file. So the README file will contain 2 or 3 changes now, A, D, and E. And then we'll have a second file called second.md that's only on foo. So to be able to make these changes, you first have to check out trunk. Now you need to make these changes one at a time onto trunk. So I'll use the identical process here. I'll do D, and this is going to go to README. I will add it, I'll commit it with the message D. Very important to do that. I will now add the next commit, which is going to be E. Add it to README.
Add it to README, to the trunk.
Stage it, and then commit it with the same message. So now, if I were to do a git log, I'll do one line this time. You will see trunk points to E, which has D and A in the past. I can actually use git. Do you know you can use git log with the branch name? So I can do foo, and you'll see foo CBA. Perfect. So we has D and A in the past. I can actually use git. Do you know you can use git log with the branch name? So I can do foo.
You can use that with a branch name.
And you'll see foo CBA. Perfect. So we have these two setups now. I can see trunk is correct. I can see foo is correct, and I have this setup right. Branch name. So I can do foo, and you'll see.
So you can look at this.
Trunk points to E, which has D and A in the past. I can actually use git. Do you know you?
Exactly. So git log one line to look at the current branch, which is now a reference, which is now a SHA that contains the state of your repo. All right, and you can also inspect it's another branch that contains the state of the repo and a different version.
You can use git log with the branch name. So I can do foo, and you'll see foo CBA. Perfect. So we have these two setups now. I can see trunk is correct. I can see foo is correct. And I with the.
So let's go to now create that.
This time I do want you to edit the README file. So everyone has this set up. So now we're going to need to do the exact same thing to trunk, except for we want to have D and E. This time, with the previous section, you should have this set up. Hopefully everyone has this set up. So now we're going to need to do the exact same thing to trunk, except for we want to have D and E.
Exactly. So now we want to have this desired state. So now we want to have this desired state, which is let's finder. You got is this one. So all right, good. So what we can do here is to recreate the same as we did on the past, which is here we're going to now branch or check out to trunk. All right, and then you say, hey, echo. Here we want us to echo is D and A. All right, you can say echo D followed by that on the README. Okay, echo that. Echo D, git add the README to this, and then git commit with the D. That's right. And also I want to add a new change to this, which is git echo, but now with the value of AE, okay.
And commit it with the same.
Echo A, and then concatenate that output on the README file. So append that at the end of the file here. So I can now say git add the README, and then git commit, but this time is with the letter E, right? So if we look at this git branch or git log, one line here, you can say, hey, I got this one. So after I create them, all right. So after we create those files, So after we create those files, we got this. And we want to check the logs here as it is. So you can see now that we have is this, all right? Of a trunk. So git log, this is git log one line, you can see this. One line, you can see this, all right? Or if you say, hey, git log, this is one line, git log, you can pass is the branch that you want to check, for example, foo, and then you got is this, right? So git log one line with the foo branch, we got is this. All right. Remember, all of those SHA are containing now the state of the repo.
Message. So now, if I were to do a git log, I'll do one line this time. You will see trunk points to E, which has D and A in the past. I can actually use git. Do you know you can use git log with the branch name? So I can do foo, and you'll see foo CBA. Perfect. So we have these two setups now. I can see trunk is correct, I can see foo is correct, and I have this setup right here. So now it's time to merge these two together. There's actually two different ways you can do it. There's merge and there's rebase. We'll go over rebase at some.
Okay. So now let's go to merge them.
Point, but we're going to start first with merge. Now remember, a commit is just a set of changes in the entire code base at a specific point in time.
Exactly.
Go over rebase at some point, but we're going to start first with merge. Now remember, a commit is just a set of changes in the
A commit is just a set of changes in the entire code bases. So now remember that a commit is a code change. Yep. Now remember that a commit is a code change. So now remember that a commit is just a set of change, okay, to a code base, to the entire, exactly. So it's just a set of change in the entire commit. So now remember that a commit is just a set of state. Okay. So now remember that a commit is just a set of change in the entire repo or the project that is being tracked.
The entire code base at a specific point.
At the entire repo at a specific point in time.
And if you have work on one branch and you need to get it over to another branch, we're going to use merge. Now, the thing about merge that's a little bit confusing is that when you use merge, you can have kind of two different outcomes. You can have one that has a merge commit and one that doesn't have a merge commit. And you've probably experienced this where sometimes you merge and you.
Okay. So you might have two scenarios when you merge. Is exactly, you might have two scenarios when you merge. You might experience commits, you might experience is merge.
You have to input a message, and then sometimes you merge and you don't have to input a message.
Exactly. You may experience inputs, message to put at, or don't.
And there's a very specific reason why, because it depends on your history. We'll go over that.
Mm-hmm. And it is depend on your history. And here we are.
In just a little bit, we'll create the two situations which exist. So what is a merge? A merge is just attempting to combine two histories that may or may not have diverged. Diverging means like how we set it up. A is in the past, and we both share A, but there could be 0 or more commits in both branches that cause us to diverge. Now, whenever you are merging, Git uses something called the best common ancestor, which is going to be the first in common commit. So for us, we have ABC and we have ADE. A is the best common ancestor. In the docs, you'll often see it's called the merge base. And so really, it's just the first thing that's in common. So if you were to walk up the tree, like if you were to think about you having to write this algorithm, you literally start at each commit and you just keep on walking the parents with the hash map, by the way. You'd want to use a hash map here, unironically. You'd use a hash map to contain, or really a set, to contain all the things you've seen up to this point, all the commits you've seen up to this point. And the first time you have something that is in common, you know you've just found the best common ancestor. Funny enough, it's always a hash map. I don't know why, but it just always is. Anyways, Git then takes these two commits that you have.
This is interesting. It's always a hash map, man. As a way to compare these two stuff here.
Know you've just found the best common ancestor. All the things you've seen up to this point, all the commits you've seen up to this point, and the first time you have something that is in common, you know you've just found the best common ancestor. Funny enough, it's always a hash map. I don't know why, but it just always is. Anyways, Git then takes these two commits that you have, checks out the merge base or the best common ancestor, then plays those commits on top of it, creates a new commit called a merge commit, and that will actually have two parents. You'll have one parent from one branch and one parent from another branch, and that is a merge commit. And so this happens, that's what you'll get a message because you have two different diverging branches. So we'll go over that. Here we go. All right, so how to merge, very, very easy. You have a target branch, which is the branch you are on, and you have a source branch, the one you wish to merge with. And the source branch is going to be the one that you provide the name. This is how I think about it, at least. I think this is probably...
The source name is the one you want to provide the name. Okay, I want to merge. Okay, so right now I'm the...
And that will actually have two parents. You'll have one parent from one branch and one parent from another branch, and that is a merge commit. And so this happens, that's what you'll get a message because you have two different diverging branches. So we'll go over that. Here we go. All right, so how to merge, very, very easy. You have a target branch, which is the branch you are on, and you have a source branch, the one you wish to merge with. And the source branch is going to be the one that you provide the name. This is how I think about it, at least. I think this is probably the easiest way to think of it. And
so the branch you are on is a target, and the branch, which is the branch name, is a branch that you want to merge with. It's interesting. Okay. So this is where I am right now, and this is the branch that I want to merge with this.
And so you'll do git merge the branch you wish to bring onto the one you're currently on. So let's do it now. Let's merge foo onto trunk. But remember, we don't want to ruin our current trunk state, so I want you to check out a branch called trunk.
So it's going to merge the foo onto trunk.
Merge foo. Foo onto trunk. But remember, we don't want to ruin our current trunk state, so I want you to check out a branch called trunk merge foo.
Okay.
So I'm going to go git check out trunk merge foo. Have my new branch. Remember, dash B just creates a new branch if it doesn't exist. Awesome. So now I'm going to go git merge foo. There we go. We're presented this menu saying, hey, we need you to merge this. Awesome. So now I'm going to go git merge foo. There we go. We're presented this menu saying, hey, we need you to merge this together. We want you to add a commit message. It's been auto-merged for you, but we still need a commit message. Because remember, a commit is a series of changes that represents the entire state of the repo, plus an author, plus a message. And time as well. You probably see something like this, merge made by ORT strategy. That's relatively new. I think at one point it used to say like a three-way commit strategy, and now it's changed into the ORT strategy. All right, so when we're done, I want you to use git.log. So everyone that has just merged, use git.log and see what happens. And I also want you to use the term parents when you do git.log, or git.log. When you do git log, I want you to add -- parents. So show the parent commits along with everything. So I'm going to go git log, one line, graph, parents. So you can
And we are now in trunk merge here. Git log one line graph parent. So here we can see is now the common known ancestor, which is A, and now the changes from trunk and foo, right? Which is containing is A and D, and foo containing is C and B, all right? And then we merge them into this new branch, into the new commit. Okay, into this new commit that is okay. Into this new commit here. So we create this, and that's interesting because okay, since we create now is the branch here from trunk, okay, and trunk containing is the A and B, okay, and trunk containing is the A and B, exactly, and trunk from trunk, and trunk containing is the A, D and E, okay. This is where we put it here, and we want us to merge is trunk that hasn't, and we want to merge is trunk or this new branch, which is a new commit, the new state of or the commit, because we want us to, okay, so we create now a new branch, aka we have a reference of that commit where we create that, in our case trunk. Now we want us to merge, which is this branch trunk, which is now a branch of the trunk merge foo, which is now a branch of trunk, okay. So I want to now create now a commit from this, or I create now a new branch here that has a reference to that commit of that branch, okay. And then I want to merge change from another branch, right? In this case from foo. So I want to now merge the target changes in from trunk, which is trunk merge foo, with the change of foo. So this is when it needs to look at the common ancestor and then apply those changes. And if there are any conflict, well, you need to resolve this. So you can see here the merge commit has two parent. The merge commit has two parent.
see right here, the merge commit.
The merge commit has two parent. Okay. The merge commit has two parent. The B7 and the 24. 24 is 24. Is it true? Okay. It has now, the merge commit has two parents.
Has two parents. If you look at this ID, the SHA, you'll realize this is trunk, where trunk is currently pointing to. When you look
Which is the state of the app at that moment.
at this one, this is where foo is currently pointing to. This is C. This is E. And then now with the graph, it's able to draw this nice graph because it has all that information. It's able to walk back the graph and be able to display it for you so you can actually see in line what is happening. So there you go. That's pretty neat, right? By the way, log, totally underrated. Super cool utility to kind of know some of the things to use. All right, so now I want you to create the following Git setup. I want you to check out trunk, then I want you to check out a new branch called bar, and I want you to add two commits, X and Y. And X and Y, please put the changes into a bar.md file or just some other file that's not README. I used bar.md.
Now has two parents, bro.
So I'll do it with you. Git check out trunk, git check out dash b bar. I'm gonna echo in X, into bar.md.
You change to trunk, you add some change. Okay, you change to trunk, you create a new branch from that, which is creating a new reference of that commit of that branch. Okay.
I'm gonna add it, I'm gonna commit
some changes.
I'm gonna do it again with y.
And that's right. And you're gonna do that.
All right, anyway, so we've now created this right here. It's pretty straightforward. All you have to do is just check out bar, add the two commits. This is almost identical to what I just got done doing on the screen. Pretty easy. So we should now have the exact same thing. We should be able to use get log to see that we've done this correctly. So I'll do it right now, and we'll use the exact same get log that we're always using with
log one graph parent.
One line, and we can erase parents. You don't really need to know parents. But you can see here, bar is at y.
Exactly, but this is from the bar.
Trunk is at e. Can you say anything that's unique about this situation that wasn't even no parents? Same thing. We should be. Why? Please get set up. It's pretty neat, right? Graph, because it has all that information. It's able to walk back the graph and be able to display for you, so you can actually see in line what is happening. So there you go. That's pretty neat, right? By the way, log, totally underrated. Super cool utility to kind of know some of the things to use. All right, so now I want you to create. So there you go.
It's a current commit that contains this change of the entire. It contains that the set of change of the entire project, okay, and these two common ancestors.
It's pretty neat, right?
Where the merge
By the way,
happened.
Log, totally underrated. Super cool utility to kind of know some of the things to use. All right, so now I want you to create the following Git setup. I want you to check out trunk, then I want you to check out a new branch, other file, out-add it, I'm gonna commit it. All you have to do is just check out correctly. So I'll do it right now, and we'll use the exact same. Can you say anything that's unique about this situation that wasn't unique in foo, or that was different in foo, shall I say? Correctly. So I'll do it right now, and we'll use the exact same get log that we're always using with one line, and we can erase parents. You don't really need to know parents, but you can see here, bar is at y, trunk is at e. Can you say anything that's unique about this situation that wasn't unique in foo, or that was different in foo, shall I say? What's different between this setup versus what was done with foo and trunk?
That we have now won the history.
Foo and trunk both diverged. In this situation, bar is the only one that has diverged. Its best common ancestor is the tip of trunk. It's a very important thing to remember, or to observe, shall we say. So now let's merge bar onto trunk. So do the exact same thing, and this time we do not create a separate branch, just check out trunk and merge bar onto it. So I'm gonna go get check out trunk, get merge bar. And you'll notice.
So what it's doing behind the scenes is say, hey, I want you to merge is this commit, this state of the repo with another state of the repo that you stored previously, all right? Yeah. And if there are any issues, so when you to prompt is this input.
But this time, there's no commit message. Why is there no commit message? Again, the best.
Because the best common ancestor was the tip of the branch you are making.
Common ancestor was the tip of the branch you were merging onto, which means that it can just take the commits and just update the pointer. That's all it does. It doesn't have to do any sort of merging. It already works. You've already resolved any conflict. It can just simply fast forward the merge. So you'll often see in the documentation where it says ff-merge. It literally means you have a linear history with no divergence, and you can just simply take the commits and update the pointer. All right, so now we're gonna go from merge to rebase. I know everyone's excited about rebase. The thing about rebase is I am completely convinced people don't like rebase because A, they heard on Twitter that it's bad. B, they used rebase that one time, screwed it all up, and now they hate it and it's ruined their life. Therefore, rebase bad. It's not bad. It's actually fantastic. Rebase is just yet another tool in your get bad belt to be able to manipulate and use your repo effectively. There's actually a really good reason why you should use rebase. We'll kind of get into it a little bit more. So this is our current setup right now. We have foo, which is BC, and we have trunk, which is all the way up to Y at this point because we have merged on bar. So this should be your setup right now. Now we can demonstrate the power of rebase by updating where foo points to. We're gonna create this graph by using rebase. This is what rebase does is it allows foo points to. We're going to create this graph by using rebase. This is what rebase does, is it allows you to update underneath your set of changes. And this is very important because it is rewriting history in some sense, is it where foo points to. We're going to create this graph by using your setup right now. Now we can demonstrate the power of rebase by updating where foo points to. We're going to create this graph by using rebase. This is what rebase does, is it allows you to update underneath your set of changes. And this is very important because it is rewriting history in some sense, but it's allowing you to have what is currently the reality, then your changes. As opposed to your changes that are tested against some previous reality that's no longer true, you can now have it properly in line and then to be able to find out, did you actually write something that's good or does it suck? All right, and this also means when we decide to merge foo onto trunk, we can do a fast forward merge. Because again, our best common ancestor, our merge base, is the tip of trunk now that we rebased. And this is typically why people really like rebase, is that it allows no merge commits. And there's a good reason why you don't want merge commits, and we'll cover a little bit later. All right, so basic steps of what rebase does. First thing rebase does is that you will first go git rebase target branch. Second, what it's going to do is it's going to actually check out the latest commit on the target branch. So you're no longer on your branch. You actually switch branches to the target branch. Then it's going to take the branch that you were on, the current branch, and play the commits one at a time in order onto the target branch. Then it will update. Then it'll go back, check out your current branch, and update current branch to point to that latest commit. So therefore, it actually just moves your commit forward in time and plays it one at a time. So that's how you got to think about merge. It's a little bit, or rebase. It's just a little bit different. But it's very important to understand that because down the line, rebase is going to cause a lot of problems if you don't know about that specific feature. All right, I want you to rebase foo with trunk. Create a separate branch called foo rebase trunk. And so you're going to do literally do a git rebase trunk on this branch. So I'll do it myself too. I'll check out foo. And you can do a git log if you're curious, right? There you go, ABC. And so then I can do one on trunk, AB or ADEXY, and then I can go git rebase. Oh, git checkout. Almost messed that one up. There we go. We'll create the new branch, foo rebase trunk, and then I'm going to go git rebase trunk. All right, we've rebased. So what happened? Well, let's look at the log. Git log, one line. Look at what we see. We see trunk. But we also see our two commits that differed from trunk now after Y. We now have history that is linear. So now you see that trunk, which contained bar as our last merge, is now the base for foo rebase trunk. In other words, foo is no longer diverging from trunk. It's now linearly walking the history forward, which means we can fast forward merge if we want to. So there are some pros. Obviously, you get a clean history with no merge commits. So if you use git log to kind of look through things, if you want to walk backwards through changes, there's just significantly less kind of commits to have to go through. The cons obviously are that it alters branch history. And when you alter branch history, if you have the same branch on another repo, you then have a problem because you have two branches named the same thing with two different histories. And so this is typically where you see that git push force because you want to forcefully tell the other repo, I know what foo has, and my version of foo is more correct than yours. So you need to update everything. All right, so some cautionary words. Never change the history of a public branch. I believe Mark over there, Mr. CEO, actually has done that once before, and it's a mega pain. It's a super pain. Don't ever do that. So typically what you'll see is always merge on public branches, rebase on private branches. So you have some changes. You want to make sure they actually work. Super pain. Don't ever do that. So typically what you'll see is always merge on public branches, rebase on private branches. So you have some changes. You want to make sure they actually work with the latest part of your, whatever you're working on. You can then rebase it forward, run your test, run whatever. Everything works. If you have a conflict, you're going to have to resolve it. That way you have your private branch being altered in history, but your public branch never changes history. The moment you do that, it breaks everybody. Everybody breaks the moment you change public history. So don't ever do that for any reason. There's a lot more, but we need some more foundational knowledge before we go over it. So we kind of have a nice little base here. Now you know branches, merging, rebase, you kind of get how they work. You understand how commits work. You actually understand that it is the storage point of the entire repo per commit, but it's efficiently stored, so it's not a waste of space. This is also why whenever you're downloading a Git repo that is has a long history, it takes a while because it's literally downloading every single change possible because it needs to be able to reconstruct the repo at any one time. That's also why if you do a Git clone and use like depth 1, I believe is the proper option. You'll actually just clone it down with only the last commit, which will contain the entire repo. That's how you get that efficient checkout. Clone and use like depth 1, I believe is the proper option. You'll actually just clone it down with every single change possible because it needs to be able to reconstruct the repo at any one time. That's also why if you do a git clone and use like depth 1, I believe is the proper option, it will actually just clone it down with only the last commit, which will contain the entire repo. That's how you get that efficient checkout. We're going to talk about head. You've seen it already. It's been in the logs. You see this constant head dash, whatever branch name. It probably is a little bit confusing. You should rarely use it if you don't if you don't have to. You should try not to play with it. You know, it's just it always causes so many problems the moment you start checking things out. But if you know how to use it, it's fantastic. I use it all the time for interactive rebasing. I'll do like a head ~6. I'm able to squash everything. It's fantastic, but it can also be a pain. So throughout this course, you'll see this. So what is head? We can do some experimenting. So what I want you to do is I want you to check out trunk. And then I want you to execute log 1 line. Now add a little 1 line there. You'll see head points to trunk. Everyone should see that. Let's do it again. I want you to check out foo, and then I want you to do another git log 1 line. So git check out foo, git log 1 line. Again, head's now pointing to foo. So it's like every time we change branches, notice that head's pointing to whatever branch we have checked out. Okay, this is important. Go check out the git folder and tell me what head is pointing to. So if you go in here and you go ls git, you'll see that like named item is just a top level item in git. So if I cat git slash head, oh my goodness, just autocomplete. You'll see right here, it's a ref to foo. That's all it is. It's just this thing that exists right there. It's just a pointer to whatever you're currently using. It's really nice. Like once you see that it's just not that magical, that means if I go cat refs or git refs heads foo, you'll see it's just a commit. Like we're walking through, starting at head all the way to the exact commit, and that means I could reconstruct the repo now that I have this commit, and we did that earlier. So we can actually go all the way from head to the exact file that we want to look at. And so this is kind of how that works. It's just good to have in your head how it works. Didn't even know that was going to come out. All right, here we go, reflog. It's actually not a wizard's tool. It's just not. It feels magical, but it's really like, it's very one-dimensional. So reflog just shows you where head's been. So give reflog a try. Oh, I just told you. I unfortunately just ruined the moment. Just execute git.reflog and just look at it and see that it followed how you've changed your branch. So if I go git reflog, you'll see that, look at that, moving from trunk to foo, from foo rebase to trunk. You can just watch me.
Commit A, commit D, check out moving from foo to trunk. Commit C, commit B, check out moving from trunk to foo, check out moving from trunk to trunk. So it's like giving you the head.
Change each one of these, and it comes with the commit SHA for each one of those items. This is when I was at B. Remember when we goofed things up way earlier in the repo? You can actually see me doing like a what's it called? A reset. Like you can actually watch me do all my oopsie daisies. We redid everything right here. Look at that. So you can actually see the entire history of all decisions you've made in your repo by looking at reflog. And all it is just simply the log of where you've moved. That's it. Nothing magical about it. It's very, very simple. Do you think you can find where reflog is stored in the git folder? Is it a log? How do they store it? All right, so if I go here and I go like this, if I just ls git, you'll see, oh, look at that. There's a logs folder. You know, that feels pretty serendipitous, right? So what's in the old logs folder? Well, look at that. There's one called head. What do you think's in that file? Let's just pretend that I don't know, and let's cat it out. Huh, does that not look pretty dang familiar? Reflog is just prettifying this file. At least in its default basic usage. There's a lot of options. There's always a lot of options. In fact, you can even use git log to create reflog with a whole bunch of options, but we're not gonna do that. Just this right here is as simple as it gets. At AOL, yeah, I did AOL. For those that are laughing, I did AOL.com. I thought it was funny. It's a great email, okay? All right, solution. You can do a reflog -3, and you can actually see 3 lines of your reflog. So if you don't want the whole thing, you just want to see a little bit, you can actually give it how many lines you want. So if I go get reflog 3, I see 3. That means if I cat out my head and go tail 3, you can see the last 3. And you'll notice they kind of look, they're the same, right? You can see here moving from trunk to foo, moving from trunk to foo. So there you go. It's inverted. The last line of the file is the first line in reflog. It just takes the file and inverts it. That is it. So there you go. Now, hopefully again, the magic is being slowly spoiled, and now the real magic happens, which is how simple Git actually is and how powerful it really is. That's where the real magic is in the use. This will be kind of a weird task to do, but it'll be fun. What I want you to do is I want you to create a branch called Baz. I think currently we are on foo. You can create on whatever you want. It doesn't matter about the base branch you're branching off of. I want you to create a branch, or I guess I say do it off of trunk. It really doesn't matter, but let's just for now just say create a branch off of trunk called Baz. Add one commit to Baz and do it in a new file. Right? Don't do it in README. Do it in a new file.
Okay.
Switch back to trunk and then delete Baz. And then I want you to bring Baz back to life from just the SHA. And we can discuss how you do that. So first do the first three, and then we'll kind of talk more about this last.
Exactly. So create a new branch of trunk called Baz, add one commit to Baz, do it in a new file baz.md, switch back to trunk and delete bash. Git branch delete from early, and you can bring back from that the commit SHA.
And I'll join you. I'll go git check out trunk, git check out -b Baz, echo,
using this reflow
Bazzy.
by
to Baz, git add, git commit. Definitely my best work here. Git check out trunk, git branch delete, Baz. Dang it.
All of the decision that you have.
I just lost all that work. And, oh, darn it, I just lost all my history too. I could have probably recovered it if I didn't control L, but now look at this. I'm up a river without a paddle, right? Well, hopefully you don't think that. Or I think this is a fun kind of exercise to go on. So let's first use reflog and let's recover our SHA. So what I'll do is I'll go like this, git reflog. I know it's in the last couple, so why not just do a -5 so you don't see your entire history. And look at this, definitely my best work. Okay, so that's the SHA. We have the SHA from that commit, which means what can we do with the SHA?
Look it up.
Rebuild the whole repo.
We can rebuild the entire repo just from this one little tiny SHA.
Exactly.
Right? Remember, git cat file -p this? Look at that, it's right there. It's still in Git. Just because we deleted the branch did not mean we deleted what you just changed. It's in Git. The files are in the computer, as a wise man once told me. All right, problem. With our sweet knowledge of how Git...
This is on the computer. Exactly. The file is in the computer. Exactly. So when you delete that, you don't delete that locally. You just delete is the reference to that. But the Git head is still keep tracking
Git plumbing works. Can you retrieve the contents of the commit using our super awesome powers to grab out baz.md? Can you do that? You have the SHA. Try to get out what was in baz.md, not from your memory, but from Git.
So you're going to navigate.
So we can use git cat file -p with that. I can go into the tree, git cat file -p that. I can see my little Baz file right there, and then I can git cat file -p that thing, and look at that, Bazzy. I recovered it walking the SHAs all the way to the exact file. So I could take this, and I could cat that, and I could pipe that into baz.md, and then I could git status, and look at that, git diff. We actually don't have anything in there because it hasn't been added. We could add that, and then git diff staged, and look at that. There's Bazzy. It's a new file right here. Oh my goodness, I've just recovered it, and I feel like a hacker, right? I mean, there is actually easier ways to do this, but that was just kind of fun, right? Pure wizardry. You do this at your job, you're getting a promotion, right? Like just right off the bat, Brent, CTO, front-end masters, will just hire you as the new CTO, just doing this.
Absolutely.
All right, let's not use the internals. Is there another way? I mean, it's great flexing, right? You should always flex that work when you can, but maybe you don't have to. Is there an easier way to do this? Well, you can always just do unfortunately, here, hold on, I'll go like this, git reflog. Let me just have this thing out right here.
In chat, someone mentioned cherry pick.
Shh, chat. All right, so one thing I can do, if I really wanted that change in trunk, I could git merge just that SHA. I already have the SHA, right? I could just bring it in. Git still has the state. Boom, look at that. Baz is now in trunk. Wow, that was magical, right? We didn't have to do all that hackerman stuff. We just simply needed the SHA, and then we can just merge it into trunk. Now I have Baz right there. It's just right there. Kind of interesting, right?
Because
you might not have seen that one coming.
Of the application with the SHA.
So we can do that. But there is a problem with merge. What happened if there was a lot of diverging that happened? What happened if there's a bunch of commits in betwixt my trunk head and that commit? What would happen if we merged it? we'd get all that history, right? Because it's going to try to find, what does it do again? It walks back, it finds the merge base or the best common ancestor, and then it replays all of those potentially into a third branch and then does a merge commit if the histories have diverged. So you may not want to do all that, right? That may be kind of a pain. Maybe you just want that commit and not everything else.
Exactly.
Well,
Maybe you just want that set of change that.
I don't know if you know about cherry pick, probably never even heard the term until this exact moment, but cherry pick allows you to take just one or more commits specifically. Cherry pick is fantastic. I've used this probably as one of my 20% commands. I probably have used this the most. It's just because anytime I have just that change, I don't want to merge, I just want this one diff, cherry pick it in. And it works with remotes. It's fantastic. Long as you are up to date with your remote and you have all the changes from them, you can just cherry pick a singular commit into your project if you need to. It does require your working tree to be clean. Remember, working tree is just the state of your project, everything that's been tracked by Git. So no changes to your working tree, and then you can cherry pick, and no changes to your index either. Sometimes if you have like index problems, you can it will say no. Index again is the staging area. Remember, it's not necessarily your working tree. So there you go. So get cherry pick. Try if you haven't done it. See if you can cherry pick the change of Baz into trunk if you did not merge it in. So all you have to do is, of course, get cherry pick and the SHA, and it will just merge it right in. Fantastic. Oh, really? Real talk. It is like by far one of my most used commands is cherry pick. Absolutely, just has saved my bacon more than once. Because have you ever had like a change that has diverged so bad due to something, and then you just get the merge conflict is just incomprehensible. And this has happened to me. And luckily, you've made some small commits, and you haven't made one big commit. You're like, I'm just going to take out these two things, play them over here, and then try to rebuild the rest of it. I've been in a situation where it was such a bad divergence that the only way forward was to actually just like hand move things over, and that was with cherry pick.
Holy moly.
Do you feel more powerful now? Is your Git knowledge growing, hopefully? Well, now we're gonna talk about remote Git, right? Often we need changes that have been created by our fellow frenemies. Frenemies, of course, is because they make code and it hurts your feelings or hurts production's feelings. And but how do we get their changes into our repo? How do
Fellow frenemies.
we push our changes to their repo? Here's one thing that kind of, I guess,
A mi enemigos. A mi enemigos.
will surprise most people is that it doesn't have to be remote. It doesn't have to be on GitHub. I know that might be strange because often when people think of Git, they think of GitHub. They don't actually think of Git as its own thing, and then GitHub as a means to store Git. They think of GitHub as Git. So you may have never really used Git as remote. Like, you just probably never done this. Why would you have the same thing twice? A remote is just simply a copy of the repo somewhere else. That's it. So I want you to create a new folder wherever you create folders. And let's call it remote Git. And I want you to initialize it with git init. So I'll jump in here and go, I'll go my personal directory. I'll make dir remote Git. And then I'll go into remote Git.
Okay.
There we go.
So that'll be all for this video. Take care. Bye-bye.